didn't, you wouldn't know. The early Earth could have been alive without producing this much oxygen, but maybe not. Anyway, I'd like to wrap up. I have a movie that's similar to the one that Mario showed you. This is the Harvey-Survived moon rocket blasting off, carrying something that an astronomer might like to have. Show you how it might carry something way out to the Lagrange point with a telescope to look for whatever you might want to look for. A telescope carried in the moon rocket would not have to be folded up the same way. You could have a nice big circular piece of glass. The moon rocket is capable of carrying about 60 tons, 60 metric tons out to the Lagrange point. Roughly 10 times the, well, James Webb Telescope will be 6,000 kilograms, so about 6 tons. So roughly 10 times the mass can be carried out to the Lagrange point. The moon to the Lagrange point, and then we'll close with some places you can get more information and think about it all. So this telescope looks a lot more like the telescope you might be expecting. This looks a lot like the Hubble, only bigger. So it could happen. Survey. You will find this website and you can read vast amounts of information about astronomy. You can also look for books, including The Very First Light, which is a book that I did, tells the story of the COBE satellite and has a new chapter about the Nobel Prize. So thank you very much. I'm happy to have a few questions if we have a few minutes.
Bravo.
We have time for like 2 questions. So we have one right here.
What you talked about Jupiter and Saturn changing positions. What was the mechanism that caused that? Have you heard what the reason?
Yeah, the orbits of a system are not necessarily stable. In fact, the more that we know about gravitating systems, the more unusual it seems to be that a set of orbits like our solar system has would be stable. So if you start them off a few millimeters different from where you think they started, the result will be completely different. So if this is just the mutual gravitational interaction of the planets with each other, and with tiny little bodies that happen to be left over as well. So, as I said, Newton gave us this clockwork universe, and it's not clockwork. It's chaotic.
I wanted to know what you thought of the possibility of using the far side of the moon as an observatory, like a radio observatory.
Okay. The far side of the moon as a radio observatory is one of the leading possibilities for what scientists would want to do astronomy on the moon. The retroreflectors that tell us about gravitation that we have had since Apollo, those could be upgraded, and that would help us study the dark energy, and the dark matter, and things like that. The radio telescope on the far side of the moon is certainly a gleam in our eye. We have precursors to that are being built on the ground and deployed in places like Australia to see what's out there. When we get to the end of what you can do on the ground, I think people will say, you know what, we need to go to the far side of the moon for the next step. So it's pretty hard. We can get pretty far on the ground, but eventually we need to go there to do the next step.
It's quite a leap from life to intelligence, but there are optical telescopes now searching for laser signals. So I just wanted to add that for the sake of completeness.
Yeah, sure. It's definitely worth looking. The odds of success are small, but it's definitely worth looking.
Okay, great. Thank you.
Okay.
Bravo.